oftentimes running just a deployment isn't enough. We need to be able to integrate with external systems or fill in blanks that the platform doesn't provide. For example, Infoblocks, this isn't NDA comment or content, so I can share it. Infoblocks is not in the platform today, the ability to bind to an IPAM provider. It's a very short-term roadmap item. It's coming very soon, the ability to bind an Infoblocks appliance here. But we have customers right now who said, hey, I can't do this without Infoblocks integration. Something that VMware and VRA has always done fantastically is create a mechanism for being able to integrate with external systems. And we do that via the event broker, VRA's orchestrator as an orchestration platform. But we've also introduced something called ABX. And ABX is a function as a service platform built directly into cloud automation services. Today, it uses AWS Lambda and Azure functions. And you can write those natively in Python, Node.js, other languages are coming soon. But to answer your question, you could absolutely use extensibility to call that via AWS CLI, right? Because AWS CLI comes bundled into Lambda, generally, so you can actually call those directly. So in a pinch, if there's something you're like, hey, I love the platform, I love what I'm doing here, there's just that one thing that I need to be able to do, you could absolutely call it via extensibility. What you would lose, and again, I'm nothing if not transparent, what you would lose is the day two management of that provisioned object. Because if you say you did that and you provisioned out an EC2 spot instance, spot instances are not in the platform right now. If you use the AWS CLI to fire off a spot instance, silly example, but when you destroyed that primary deployment, it would go away, the spot instance would remain because there's no day two around the extensibility of that. You could write that in, but you would have to write it on a one-by-one basis, which is why the feedback loop is important to understand what functionality is missing so that we can add that in so that you get the day two management capabilities of it as well. Yeah. Where I was going with that before is that the turnaround time is actually very quick and not like vendor VMware quick, like Cody judgment quick. It actually is fairly quick. Yeah. But it is still a time, and that is still a barrier and something we need to improve on. So talking a little bit of extensibility, and after this we'll wrap this section and move on to talking a little bit more about applications and exposing them into the catalog. We have this concept inside of cloud automation services that's known as the event broker. And the event broker is a set of lifecycle states that the platform is aware of around machines and resources that deploy into it. And that's part of the kind of hidden gem of VRA and now CAS is the fact that we are aware of a machine lifecycle. So as a machine's powering on, right after it powers on the first time. As it's cloning, right after it clones. And being able to run extensibility items attached to that. And that's how we do things like Active Directory pre-stage. It's a super common thing that customers do. They say, before an object can be joined to the domain, I have to have that object created in AD, so I join to it. I don't allow systems to just join arbitrarily. I have to have the object in place and join onto it. We do that via extensibility today. Same thing applies to things like DNS. I need to, before a machine powers on, I want it registered in DNS, or I want a record for that in DNS already available. I want to call the IP from IPAM before the machine clones. That way I can apply the new IP to it, and I'm not just using DHCP for all the things. So we can do that by creating what's called a subscription, which means we subscribe to an event type and bind it to an extensibility action. Spinning, spinning, spinning. Oh, there it was. I was too impatient. So for this one, I'm going to do a Slack notification. So I'm going to have the system notify me on Slack whenever a machine deploys. So we'll go Slack notification for the name of the subscription. I'm going to choose my event topic, and I'm going to do it on post-provisioning. And what this says on the right is fires after a compute resource gets provisioned. Now I could filter this based on custom properties. So you saw on the right as I was building up that YAML, I can add properties in there that would say that only trigger this on specific events. So for example, the IPAM solution, if you wanted it to only fire when IPAM was enabled, and you had a property that said IPAM : enabled, you could set it here and say that this will only fire when that property is detected. We're going to let it run on everything, because what could go wrong then? And we will choose Slack notify, or announce build with Slack. There it is. We'll select that. We'll have it run against any project, and we could set it to be blocking. Blocking means that this action must complete in order for the machine to provision or shut it down. So that's really useful when you're dealing with things like Active Directory pre-stage or like IPAM, where you say, I don't want you to pull an address from anywhere else. I don't want you to be able to go around and apply a static IP. I just want you to only get IP addresses from IPAM, and if that fails, you should not get a machine. That's what blocking effectively does. Now, before we allow it to run, I'll hop in and show you what that looks like. So I have all of these different actions. You can see that I am strongly biased towards Python because I'm much like Chris in that way. We'll go announce builds via Slack. And I again apologize for how horrible that is to try and read in the room. Hopefully online it's better. But this is what you're ultimately seeing on the screen is this is just native Python code. And this is how people want to write extensibility today. VRO is not going anywhere. VRO's orchestrator has always been a part of VRA. It's not going anywhere. VRO has a healthy plugin community that we can't match with ABX. ABX allows developers and administrators who are more familiar with scripting to build their own automation via Python, via Node, via whatever other languages we start to expose. PowerShell is a short-term one that's going to be coming soon. So we can take this code and have this execute every time. In this case, it's going to parse through the details of the machine. It's going to tell me my machine name. It's going to tell me the image that was used and the ID for the deployment. And it's going to send that to me in Slack every time I do a deployment. These are also able to be stored in Git. So I obviously hinted before at the fact that blueprints are going to be in there. And we're going to see that in just a moment. But I could also store these actions in Git as well and interact with them directly from VS Code, which means I get all of the type checking against that. I get all the syntax checking. Python will say, hey, your language is bad. You should learn to write better, right? Like we can do that inside of VS Code. We're not going to reinvent the wheel and bring that into the platform here. We're going to use something like VS Code or Atom or Sublime to do all of this because they just do it better. So I'll fire off a new deployment, and then we will move on to the next section of fun. So I'll click on this box, I'll do a deploy. We're going to wait for that to finish, or we're going to wait for this to finish clicking at least. There we go. So while that finishes, I want to touch on one last thing in blueprinting, so we can actually show the Slack message come through. You'll notice this is a very static blueprint right now, and on the top I have a field that's called inputs. It's very easy for me to add inputs into this blueprint and make it more parameterized. So to do that, I can come in, I can say something like disk size. A string for now. I can come in here, I can change this. When you're a giant like me, it's actually really hard to type on things that are way lower. There we go. So now what that'll do is when I go hit deploy, it'll actually prompt me for the disk size before it submits. So if I version this again to 3, we like versioning. I'll also release this one to the catalog. By now that deployment should be done. Awesome. I signed out of Slack. I'm scared to sign into Slack because somebody might be saying things that they shouldn't be saying to me on here, and I don't think I shut off notifications. That does actually look like it did. So let's see, there's a Slack bot. Oh yeah, so down there on the bottom, you can see this deployment actually completed. Operating system, it says that your machine name is Cloud Machine, series of numbers. The operating system is Ubuntu. Your future API calls can be made using this request ID. So I do that for debugging so that I have the request ID so that when I go and do API calls, I can reference that. And that is the basics of blueprinting and provisioning. Before I move on to the next section, any brief questions on that one?
You know, just a comment, and I've been trying to keep up, but what you were doing before when you were building it, and you were, let me get this right, the declaration of the blueprint?
Yeah.
Doing that is amazing and blew my mind. I cannot wait to go try this. I love it.
So what's interesting to me about that, and it's probably one of the things that excites me the most about this platform. And the truth is, it's not going to sell it anymore, right? It's not one of those things that's going to like be a feature that we can highlight. But I like that we've taken concepts that could be very, very complex, and we've given people an on-ramp to use them. And you look at the blueprinting as an example. I drag these objects onto the canvas. I don't have to code that from scratch. I don't have to know the syntax from scratch. I get the bare bones of it drug out, and then I fill in the blanks. And now that when I know that forever, and I can use that again in VS Code on my own. And it gives people an on-ramp to develop these cloud admin skills of tomorrow, right? Instead of just being like, hey, go learn infrastructure as code and let me know when you figure it out. We've created an engine. I think it sounds really corny to say, but I think that's really an inspirational thing. It's really cool to me.
It is, because I'm the noob. I'm the guy who. So when I saw that, it just blew me away. That's awesome.
Thank you for the feedback. I appreciate that.
Cody, do you think that this in some way is going to not replace, but give other options, such as, for example, some engineers, they use Terraform or Stackstorm? Do you think this would be something?
That's a fantastic question. Again, and I'm going to take the cop-out answer of where I started with about different consumption models. We are building a Terraform provider for this. So if people, and I'll tell you the value that comes from that, because at first glance you might be like, well, I'm already doing infrastructure as code here. Why am I going to do the same thing elsewhere? Terraform is a great product. I have no beef competitively with Terraform at all. There are aspects of Terraform that are in use inside of this platform right now that, from an engineering standpoint, I know is there. When you take a Terraform manifest for vSphere, it takes a specific set of parameters that come in, right? You have to be aware of the different fields that Terraform requires for the vSphere provider. When you switch that to an AWS blueprint, you have to switch providers and then fill in the new values behind that. You don't really have a truly agnostic manifest at that point. You're building a separate manifest or something completely different. On top of having to manage state and all of that, and then the fact that Terraform historically was designed for one person to be interacting with a stack. This is a platform designed for everybody in this room to be building against if they want to. So from a state perspective, it's just a different model there. But when you use Terraform and the Terraform provider that's coming for this, you get all of that agnostic concept. Your Terraform manifest now becomes one tag that changes instead of the entire structure of your manifest. You switch that tag from InvAWS to vSphere, and the Terraform manifest will go out and build everything against CAS using the API abstractions that we've built. We see it as a better together. There's always going to be developers who have grown into using Terraform and they like that. We're not trying to go and say, don't use Terraform ever. Ours is better 100% of the time, because it's just not true. But for the use case we're going for, as far as being able to have a group be able to collaborate, a group be able to adopt a platform and use a platform, a mature cloud management platform, that's what we're going after. And as part of doing that, our vision is to interact and integrate and be able to consume and partner with Terraform, not battle them.